Hi, this video is an explanation for the Cleaning Molecules lab that was posted earlier today. So this is just giving you some background on water as a polar molecule, meaning it has a slightly positive and negative end. The positive end being down here where the hydrogen is, because the electrons that the hydrogen is sharing with the oxygen are mostly between the hydrogen and the oxygen. So the oxygen is basically hogging all the electrons, and it's a negative end over here because of the electrons being mostly over here. And the hydrogen has these protons that don't have electrons like between them and everything else, so that's the positive end. Okay, that charge allows those molecules to attract each other, and it keeps the molecules close together and interfering with their ability to dissolve non-polar substances. So polar substances can be dissolved in polar substances, but not non-polar. The same ones can dissolve each other, but the opposite ones cannot. Okay, so what we're doing here is trying to show you how the water molecules being polar helps keep them stuck together, how they have a greater attraction between their molecules than non-polar substances. And I had two cups, two eyedroppers, and pennies. And the pennies were on a paper towel, and I dropped some water on one of the sets of pennies, on three of the pennies, and some alcohol on three of the other pennies. You can try this if you want, but make sure you're careful. The alcohol is just isopropyl alcohol, like you can get at the grocery store. It's the 70%, so it's the stronger one. But make sure if you do this that, you keep it out of your eyes and don't eat it or drink it. It's not good for you. But you don't have to do this. You can just watch this video. Okay. So the question is there a difference between the attraction of molecules with a polar substance or a non-polar substance? Water is a polar substance, for sure. Isopropyl alcohol has a chemical formula of C3H7OH, which gives it a polar and non-polar side. It's not very polar. It's slightly polar. Less, though, than water. And we did have to use something that's slightly polar, because if we use something that was non-polar, like oil, it would just slide right off, right? So here, the 5 properties of water that I want you to list, how you can get from these these flashcards, which I'll link in the assignment. But basically, it's talking about the fact that water is sticky. It sticks to other things, adheres to other things. That's what adhesion is. It's cohesive. Cohesion means it sticks to itself. So it does both of those things. That's one property. It has a high specific heat, so it resists changes in temperature. It's easy for it to stay the same temperature. And large bodies of water, not only do they moderate their own temperature, but they also can moderate the temperature of things around them. Okay. Low density of ice. This is a really big one because nothing else that we know about is like this. Solid is less dense than the liquid water. Glaciers and ice float like no other substance. The solid floats in the liquid. Only water. Water is a solvent because it's polar. It dissolves other substances. Okay, and it's a really important solvent for our biological processes. Okay, and then when it comes to acids, bases, and pH, there's a scale. From 0 to 7 is acids, and from 7 to 14 is bases. And water is right in the middle, and it's the only one. It's the only one that has a neutral pH. So those are those properties of water. You don't have to write all of this stuff for that question. Just write enough to know what they mean. And you're going to get more detail about cohesion and adhesion. But the definitions for that are right here. Adhesion means that water, or for anything, it doesn't just have to be for water, right? Anything that has adhesion sticks to other things, and anything that has cohesion sticks to itself. That's the difference. Okay, how does the structure of water relate to its ability to dissolve many substances? The fact that it's polar. Okay, that's talking about this discussion here that helps you answer that question. Okay, so I did a video where I took data by following these steps, testing the hypothesis, right? If there is more attraction between polar molecules, we should be able to fit more of a polar substance, like the water, in a small space than of a non-polar or less polar substance, like the alcohol. So we're going to I tested it, and I have the video already added, so you can take a look at that. I count the drops for the water and the isopropyl alcohol until they run off the pennies. Okay, and I do it 3 times per substance to get us like an average. So in my trials, I said in the video for the data that I would put the trial data in here, but I'm actually not going to because I want you to watch the data video. So, but I will tell you to get the average, remember, you're going to take each one of these trials, add them up and get a total, and then divide the total. So I'm going to put that right here, okay? Trial 1 plus, actually I'm going to make this a little shorter. Trial 1 plus trial 2 plus trial 3 gets you a total. And then you take that total and you divide it by 3 because there are 3 trials, okay? And that gives you the average. Okay? So that's how you get the average. You got to do 2 steps. You got to add up the trials first to get a total, and then you can divide the total by 3. Don't do it as one step unless you use parentheses, because otherwise it'll do the math out of order. You'll get the wrong answer. Okay, so I'm going to get rid of that. And then look at what happened and look at your data and then see what you get on the analysis questions here. Which one could you get more? Did I get more drops on? Which one? Why? And then what are two properties of water allow the drops to stick to the surface of the penny and each other? Think back to those properties of water that I asked you about in the pre-lab. It's really just asking about 2 words that I specifically asked you about already. So I'm not going to tell you the answer, but the answer is already in this document. All right. So good luck. If you missed the Zoom, take a look at this video and hopefully it helps you out.